All right, questions so far? All right, excellent. So right now we're just working on the definitions, right? All right, so let's go here. I want everyone to go ahead and take a second. Look at the function and give all of those points that I have at the bottom, A, P, Q, R, S, and B, and talk about all of the extrema for that. Okay, so Adrian, don't forget local or max, local or absolute. Those are, yeah. Okay. So you guys are doing a great job in chat. I do appreciate that. I know it takes a little bit to type it all in, but yes. So what we're talking about here is if we look at P would just, it's not saying it's the absolute highest, right? So P would be considered a local max. Q would be considered a local min, local max, local min. What about B? What would B be considered? Yep, Calvin, you guys are at, it is the end. It's the end of the minimum is in its absolute max, and A is the absolute min. And of course, any kind of polynomial function is always the easiest one for us to talk about, correct? All right, so way back when you were probably in your college algebra class, you were probably told that finding those max and mins, you had to do a lot of test points for, correct? But I want to show you, if I draw this in, if I draw the tangent line in, use a different color. Let me see if this is dark enough. Yeah. So if I draw the tangent line in, this is the tangent line at P, right? Well, what do we notice about the tangent line at P? What is that value of that tangent line? Slope is 0. Perfect. Is that same thing true down here? Is the slope of this tangent line at Q also equal to, yeah. Do you guys see where we're going with this? All of those slopes of the max and mins have that tangent line at 0. So what can we say about the first derivative? If you set the first derivative equal to 0, what is that going to tell us? Nicholas?
Hi, I just have a question. It's not about that exactly, but it's
okay.
So in this one, A and B is the minimum and maximum. But in the last one, at the endpoints they weren't. Why is that?
Okay, because of the one little tiny word, absolute.
Okay.
Okay, because of that. And that's, you know, thank you for Nicholas for asking that question, because that's what I was trying to emphasize with the last piece, is because A, in this case, A is my absolute minimum, and B is my absolute max. Where before, in the last slide, what was I talking about? I was talking about this idea that it was local.
Oh, okay.
No, but I'm sure there's people out there asking the same question. So thank you very, very much for asking that, because it's such an important difference in the definition of these.
Okay, thank
And
you.
when you're doing your homework, it can make you crazy if you don't see that one.
Thanks.
Yep, you're absolutely welcome. And Renee, you're absolutely right. That's going to give us the possible local maximums and minimums. All right, let's go ahead and take a look at the next one. Now, there's something interesting that happens with this, and I want to make sure you guys see it. Make this a little bit bigger for you. Yes, Lucas, that's correct. And that's where we are going. Gino, that is exactly the point of this question. All right. So in the chat, if you have it up, so Lucas was saying, so if we take the derivative, because if I go through and look at this again, and I look at that slope of that tangent line, the slope of the tangent line here, that's too thick. The slope of the tangent line here is 0, 0, 0. So those are all fine. But if I look down here at S, now S is not differentiable here. It's a cusp. So everywhere in this function is completely differentiable, but it is not differentiable at S. So S is still going to be a local minimum, but it is not differentiable at that point because of the sharp turn. Because what happens is when you're taking the limit when you're coming in, let me make this a little bit bigger, right? The definition of if something is differentiable or not is that the limit from the left-hand side and the limit of the right-hand side have to match. So if I'm coming in here for the limit on this side, I have a different value than I have over here. This is giving me a negative slope, where this point is giving me a positive slope. So it's really important to say that at f of s, the derivative does not exist. But s is still a local minimum.
Professor, I have a question,
Yes, go ahead.
and this may be redundant. How is it still a local minimum if f prime of s does not exist?
Because the local minimums and local max don't refer to where the derivative is. We are just talking about the function itself, right? F of s exists. That point itself exists on my graph. Now, if it was a hole that was there, then it would not exist.
Okay, that makes sense. Thank you.
Yep. It's just the derivative doesn't exist at that point. All right. Now, what happens at another point that's interesting is f of t. What's going on at f of t? Yeah, Freddie, you're right. You're absolutely. The first derivative of f of t is also equal to 0. But is it a max or min? No, it's not. So this is where now we're going to go ahead and get into the full definition of what we're looking at here. So where do the extremas occur? The extremas occur, actually, I have one more example. I'll go ahead and put them in there. They occur if the endpoints of the function, when the first derivative is equal to 0, and where the first derivative does not exist. However, just because any of these three happen do not necessarily mean it's an extrema point. It's only where the possibility of those extrema could exist. So let me say that one more time. At these three places, at the endpoints of the interval being, in this case, A and B, where A would be considered an absolute max, absolute min over here. B, even though relative to everything portion in this graph is lower, it's not considered a local max because it is the endpoint of the interval. Local min, max, min, max. And this, we will talk about more in next class. This, even though the first derivative is equal to 0, this is called a turning point, and we'll talk about concavity, but that's coming up next. It still has a value and it still has a purpose, just not with extrema. Is there anyone that wants to talk this one through and make sure they're on the right track and understanding it correctly? S is considered a local because in every graph, you're only going to have one absolute max and one absolute min.
Professor?
Yeah, go ahead.
So when you wrote down the extremas, but you only put the interval of A to B, I thought you're supposed to like include the local min max too.
Okay, you don't need to as long as it's any interval, but that's the so if I go back to the definition says and states some kind of interval exists, right? So in the interval that exists, everything below that point is smaller. That's why it's a local max. So you don't have to state the particular interval where that happens. It's just defining a local max and a local min occur where everything around it is either higher or lower.
Okay, thank you.
And yes, Nicholas, you're right. P is the absolute max. All right, let's try one more. I would not want to be on this if this was a roller coaster, that's for sure. As long as it doesn't go into, a constant function, we'll be okay. Nicholas. All right, so absolute, let's go through and look at this. So it has an absolute max at P. Now, is f of P differentiable? Perfect. That's why I've included a lot of those. I want to make sure that's really, really clear with all of that. All right, the absolute min occurs where? Absolute min occurs at B. Excellent. All right, local max occurs at P and at R, and the min is at Q.
Professor,
Yes.
Let me get this straight. Just
please talk it out, because this is not, it looks really easy, but it's not. Go ahead.
okay. So for the absolute max, absolute max at P, so it is the absolute max, just with the caveat that it's not differentiable.
That's correct. That's correct.
Okay. Okay. But it still is the absolute max.
Correct.
But it's also the local max. Gotcha. Okay.
Yes. Yes. All absolute max and all absolute mins, as long as they are not at the endpoints of an interval, are also local max and mins.
Gotcha. Okay.
And I'm going to say that one more time, and hopefully you can, everyone really think about that, because it helps make the definition manageable. If it is an absolute max and an absolute min, it will also be a local max and or a local min, as long as it is not the endpoints of a function. Okay, Freddie, differentiable means that that the right-hand limit and the left-hand limit are equal to each other. And that happens whenever you see this idea of a cusp. It's not going to be differentiable, because what happens is your slope as you're coming in from this side, and it's the easiest way I know how to explain it, is the slope there is going to give you your positive slope, but coming in from the other side of this line, you have that idea of negative slope, and those two aren't going to match up from the left-hand side to the right-hand side. You're going to see a lot of two different words, and we're going to use a lot when we're talking about these next definitions. One is the function continuous, and the second function is the function differentiable. Both of those definitions and those words are extremely important. You can do things and we can have definitions when the function is continuous and differentiable, and if they're not, you may not be able to use the definition.